Good morning, everyone. And first of all, I would I humbly request all our audience members to please keep their mics on mute and please post your questions in the chat box, and we will try our best to get them answered by Mr. Hannes. And also, we would like to thank you for your constant support. And without that, we wouldn't have been able to reach to our 27th episode. So let's go on with the episode. LEVs have dominated the EV sales charts in India and world over. This trend may continue for a while. While many e-commerce food delivery companies are pledging to convert their fleets to electric, it is highly necessary to have parking and charging infrastructure that can sustain this transition. So, to give us some insight into this, we are joined by Mr. Hannes Neupert, Managing Director at Energy Bus. He has been working with LEVs since 1982 and has been the driving force behind many standardization committees at the ISO, IEC, CEN, and he has also worked in more than 70 countries. A budding ecosystem in India, Mr. Hannes is the perfect person to share his views, insights on LEVs. We welcome you, Mr. Hannes, on behalf of Team Gyaniki and the audience members, and we are really looking forward to this session. Thank you, Mr. Hannes, and we welcome you.
Yes, thank you very much for the opportunity, and I'm very pleased to share some information with you, and I'm happy to receive your questions and will try to give you answers as good as possible. I would like to start with a quick tour through a little bit light electric vehicle history, and then we will dive into the future. Please join me. This is a kind of storage place. In here and also in the neighbor building, we have about 1,400 different light electric vehicles. And yeah, I will show you some of them, which may be relevant to give you some insights. So light electric vehicles is something which is not at all new. The first a light electric vehicle, an electric bicycle, was in production in 1885, and at that time technology was not that easy. And then again 1932, and in the 70s and in the 80s, and the big boost just happened in the 1990s, where it's about real big numbers, and the several hundred millions have happened in the early 2000s after the first pandemic of SARS in 2002 and 2003 in China. This has been a big enabler for personal light electric vehicle mobility, taking over public transport. Now I will continue a little bit with my tour. Also relevant is the renewable energy to be used for these light electric vehicles, so that it's really also carbon neutral. And here are some solar powered bicycles from the early days. This is the solar panel from an electric bicycle from 1982, where also I've been starting to be involved in this industry. And solar race bicycle, which raced latest in 1989. Also, I was one of the team members. And solar bicycle, crossed Australia with it, and many others. I will not go into too much details, otherwise it will take days to tell you the story about this. Light electric vehicles in all kinds of bicycle technology, sometimes motorcycle technology. It's a new category of vehicle, which is not a motorcycle, it's not a bicycle. but we will talk about this subject a little bit later. Important is also the ergonomics and to find the right form for it. So we have many different here. Why we keep this collection? Mainly it's about patents in this field, because many companies invent something and they are very proud of it, but unfortunately it's not new. So that's why it's relevant to keep all the historical bikes so that we can prove what is really new and what's not new. So many patents from very big companies we could easily delete by proving prior art. So that's why we also have, for example, some original Chinese electric bicycles here from the early days as well. Scooters from China, these are usually legal there as bicycles, but actually they are motor scooters. But that's also a very important topic. What are these vehicles? Are these bicycles? Are they motorcycles? This is a hot topic, which is still something to be solved. Also, what kind of frame materials to be used to have an efficient method of production. What becomes quite popular in Europe recently are multi-track electric bicycles with 4 wheels. Here I have some very old ones, which can also hold more than one person, which can also have solar cells on top of them to create a self-recharging by sunshine of maybe 30 to 50 kilometers a day, which is enough for most of the usages. Anyhow, Pferd bicycles from the early days, these are vehicles which have been made by pioneers of this area in the 1980s mainly. Here are some vehicles from the 1970s, from the big oil crisis, this kind of electric scooter, as well as, actually this is a car from a company Maserati from Italy, pure electric car from 1973. It's a reaction on the oil crisis. Sometimes crises can help us to change in technology. So that's why I believe the current Corona crisis, as bad as it is, it accelerates many things which are going to happen anyhow. Not only in Europe, India, China, in the whole world. This is a kind of accelerator. The electric bicycle market today is quite stunning from the quantities. Electric two-wheelers on a global scale are in the range of 35 to 40 million units a year. To have exact numbers on this is very difficult because there's not good statistics available. But anyhow, numbers are big and the growth is tremendous. And also markets which have been stable for some years made a big gain in the last year because more and more people understood that the bicycle is a very meaningful piece of transport, but also cities changed their downtowns, for example, to personal cars or restricted parking to make more space for humans in cities. And cities should be for humans first and not for cars. This is something which we learned in many countries in the world over the years, that the car-centric point of view is not a good point of view. And when I look to my travels in India, I have to say India is very well prepared, and humans often are in the middle of the transport, even unfortunately also in India more and more SUVs are on the road. I think this is something you can, when you travel international, you will see that this is not exactly the trend. But anyhow, what has made the modern electric bicycle a big success is something which was invented in 1982 by a German fellow, Mr. Gebhardt, and it was that the electric motor is actuated by the muscle power. So it's kind of like a power steering in a car. You still steer, but it's easy. And this is something which seems to be not so relevant, but it's extremely relevant. And the first pedelec ever built, which you could ride, was in 1990. Pedelec is a term, maybe I introduced this to you, this is a pedal electric cycle. So this is something which is in most countries in the world legal as a bicycle. So there is no age limit, no helmet, no insurance, no type approval, no driver license. So this means a small kid can ride it, and the grandparents can also ride it. Everywhere where bicycle is legal, also this vehicle is legal. This is something which is still under debate in some countries in the world, but at least in Japan, in Europe, US, China, this is clear that this is considered as a bicycle, but be careful, discussion is not finished also in these countries. So I'm looking forward that India is taking the fast lane to future mobility by learning from the experiences in other countries. So that's why I'm also very happy that I can share maybe part of the story today. And if you have further questions, I'm always happy to answer them. What do we see here? So this is the first pedelec ever running from 1990 from Switzerland, from the inventor Michael Kutter. Actually, he was a studied philosopher, and he understood that muscle power is the sweet spot of mobility. And just 2 years later, this is one bike from the first production from 1992. Yamaha introduced this on the Japanese market and convinced the government that this should be legal as a bicycle. All efforts in Japan before to have something which looks like this but is legal as a motorcycle completely failed because it combined the negative aspects of motorcycle, number plate, helmet, you have to ride on the road, with the negative aspects of bicycle. You're relatively slow and you're not doing the same speed as the cars on the road. So people didn't feel safe and didn't like it. So this was a major milestone which enabled the pedelec to become as successful as it is today. Another technical milestone just happened a little bit later. This was in the year 2000, the first electric bicycle ever, which was powered by a lithium-ion battery. And the lithium-ion battery has helped to improve the performance in terms of range, of weight, of bicycle likeness. So that's a lightweight, but still powerful and comfortable product with a good range. This was enabled by this technology. You can see here the first electric bicycle ever in production with a lithium-ion battery. This was in the year 2002 by National Panasonic in Japan. And actually this battery made by the company NEC Token, and the technology is still used today in all Renault and Nissan electric cars. Actually, this is where it comes from. I will show you something on the test from the Exergy Association, also headquartered here in Tana, and I'm president of it since the foundation in 1992. I will show you some test results where you can see what this means. So please Follow me? Actually, we built this presentation box once for the German Technical Museum in Munich, where we had an exhibition on this subject many years ago. This was, I think, about 20 years, almost. Yeah, 2002, we had this exhibition. You can see from our test different batteries from bikes from 4 years in a row. And this was exactly the timing when there was this big disruption in the technology. This battery was from a giant, LEVS, from the year 1999. And the weight of this battery was 10.1 kilograms. The range which we made with this bike was 15.9 kilometers. It was a lead acid battery, and it had 168 watt hours. So just a year later, we had a NiCad battery in a Sachs Elo Touring. The battery weight was 5.3, so almost half of it. The range was 34.7 kilometers, almost double of it. And then the nickel metal hydride technology, iteration of the NiCad battery is more environmental friendly. And again, it's improved weight performance ratio. 2001, 4.2 kilograms, so a little bit more lightweight, and 37.2 kilometers. And it had still 168 watt hours like the batteries before. And then we, in 2002, the Panasonic introduction of the lithium-ion battery. This was only 1.6 kilograms and had a range of 37.31 kilometers. So this was a major step. So you can see in just 4 years, products in the market have changed from 15.9 kilometers to 37.31 kilometers range. And the weight was dropped from 10.1 to 1.6 kilograms. So it is a major improvement. And only with this technology made it possible to have the modern product of a pedelec, of a light electric vehicle. As well, this technology is used in scooters, cars, and so on. So the whole modern light electric vehicle, also the heavy electric vehicle, the electric truck, without lithium-ion batteries, impossible to think about. There are also other technologies available, like supercaps. This is something which is not in any production vehicle. There have been tons of prototypes over all the years, as well as fuel cell. This was a fuel cell also used, still in production, used in cargo bikes. To summarize it up, it works. It's expensive and doesn't make any sense thanks to the performance of lithium-ion batteries. The fuel cell electric vehicle is a technology which is, from a technical point of view, gorgeous, but actually from environmental point of view and from cost point of view, I don't see any future in the next 10 to 15 years at least. Let's see what comes next. An interesting issue is battery safety. This is something which we worked for DHL, Deutsche Post, for their cargo bikes, and there have been battery fires. And especially with in the early days of lithium-ion batteries, we found that this happened quite often, and actually it still happens quite often. And it's like with gasoline cars, you have a lot of energy in this gasoline. And for example, just in the US, every year about 330,000 gasoline cars catch a fire. It's something probably you also have seen this once on the road somewhere. A car is burning. Anyhow, if you haven't seen it by yourself, you have seen it in some TV show. Anyhow, on TV mostly it's not gasoline what's burning, it's some special fire effects. But what happens to batteries? Here are some batteries from the Mercedes-Benz hybrid bike from that time. This was 1996 and 97. This was on production. And this is NICAD chemistry. This is what happens when you short circuit such a battery. You can see there's a lot of temperature, so it melts a little bit and it smells bad. But that's all. It's not really dangerous for you, your neighbors. Then we check what happens when you crush it. So there's a stem with several tons of weight pushed to one cells, some leakage, no big deal. And the most dangerous thing what can happen is when you overcharge it. You can see it's a little bit rotten here because the electrolyte leaked at that time and a lot of bad smell happened. But the housing became a little bit soft, the plastics. No fire, only gassing. So this defined the state of the safety, but lithium-ion batteries often make a lot of dirt and fire. So that's why there was a lot of consideration how to make this battery technology safe. I will show you some pictures on this subject a little bit later. Or we can also do this now, maybe just so we can finish this subject. Moment. The safety question. Actually, because of these battery fires, the question was, how can be a battery safe? And to do this, we work with laboratories. And most of the laboratories, after they've seen how dangerous these batteries are burning, they refuse to do the testing because some of the laboratories have been damaged. So this was in 2002, 3, and 4. And at that time, then we built an own lab in a former cargo container, actually still here on my yard. And another one, this is in Taiwan, in the battery or electrochemistry research institute. And we founded together with UL and TÜV Rheinland and the ITRI Institute a group which is about battery safety. So people from all over the world joined here. Not all over the world, nobody from India at that time involved yet. And we defined a testing procedure. Actually, this testing procedure from that time now is mandatory to be done on European electric bicycle batteries or any also electric scooter battery, every battery which can be removed from a vehicle is falling under this regulation. It's the EN 5064-1. And why this is so recommendable, I will show you a little bit on some happenings which happened in China. China is the country with the most lithium-ion battery powered electric vehicles. There's several millions of it. Most of the electric bicycles in China still have lead acid batteries from historical point of view, but now all the new ones have dominantly lithium-ion battery. And these vehicles are charged usually at the companies where the people work, or they're charged at their homes, or they're charged in the entrances of the homes or in some kind of bicycle parking zones. And typically this happens, these fires happen in the walkway. So this is in the entrance, there's a door, and this is just the ground floor. And the problematic thing is that when you charge your electric bicycle over there, you block the escape route from your home. And also the stairways are working, they are effectively a chimney where the fire will go very quickly from one level to the next level. And to extinguish lithium-ion battery fire, you need a lot of water. And it's kind of very devastating results often, and also in China many people died because of such fires. Here you can see typical situation where people charge their electric bicycles, electric scooters inside the apartment hallways. So now this is became super illegal in China, and people sometimes still do it. And also China is trying to make a lot of education. The fires are not always only with the batteries. Sometimes they're also because of the not good electrical installation. Why? Because people have, as you can see on the sketches from a police education program, people have extension cord with extension cord, and then they have the charger called AC-DC conversion device, something like this. And on one side you have the AC in, like this, connected to the mains, and here's the DC out. And on the bottom of it, usually there's actually in every case, every product sold in the world at the moment in light electric vehicles, which I know have this signal on the signaling or signage on the back. This house means for indoor use only. This means you should not do what these people are doing here, put it on the ground outdoors, because in the next rain, this may create an electric hazard, potential of electric shock. Many people have their electric connectors in some former water or oil bottle to prevent that it get wet. This is not the correct method to do it. And this can often cause some issues, or people have a lot of cables. Just, you can see it again more in detail. That's how people create their light electric vehicle charging infrastructure. It's on demand, and you just use a tree, and you just buy an extension cord and a multi-socket, and you prevent it. It's in a direct rain. That's happening. Here you can see the remains. It's a lot of not nice to see these things. So now the police is trying to collect these all the time and educate the people, but we have more than 400 million electric two-wheelers in China on the roads, and they forgot to think about the infrastructure. Here again, plastic bag. I've done this picture by myself in Chengdu in China. Just a total normal situation on the road. Now the government trying to have this like more clear situation. But also here you have the issue that you have an AC out LED, and you have again in a plastic bag the AC/DC conversion device. So this means that even it's under roof, the rain may still come in. It's definitively not a dry room. So the government is trying to make this safe, but that's something, there's still a lot of room for improvement. So that's why charging infrastructure is relevant for safety reasons as well, to make it easy for people to park their product safe and charge it, by the way. I will talk now a little bit, I will come back to the charging subject. I will talk now a little bit about innovation. What is going to happen most, and where are we with the product? I will show you the electric bicycle innovation with a product which you all have in your pocket or on your desk, a smartphone. And actually, today, my colleague Pratyush and we're connecting with you via a smartphone. So the video is taken with a smartphone on, and it's with mobile internet connected. So actually, we're using this technology. And what happened? The phone is a very old device, and the first phones haven't had any electronics. It's a purely electromechanical device. You even have to move your body to make a ring to call someone else. So you generate energy. Later, you still dial mechanically, and here was the major breakthrough. It became a mobile telephone. Anyhow, the first mobile telephones had lead-acid batteries, like early electric bicycles. Then nickel cadmium. So this was Motorola. This was like in the 80s. About 10 years later, in the mid 90s, you had first phones which you can actually fit in your pocket without it hurts, because they are becoming slim and the battery lasts several days, sometimes a week. Lithium-ion technology was inside. Lithium-ion batteries available for electronic devices are since 1992. So they had 10-year advance. We have lithium-ion batteries in low current devices, but for the high current devices like power tools and electric bicycles and later electric cars, this was 2002. It was not a long time ago. And then there was the major breakthrough, the iPhone in 2007. And the iPhone was just making a human dream come true. The human dream was that you can have all the information of the world in your pocket, always on hand, and you can connect, like we are now connected from many different places in the world, through a device. And the Pedelec, to my opinion, is exactly this on mobility, because it connects the human joy to exercise, move your body, have original transportation, not artificial, like you sit in a box which moves, a car. The point is that your brain will not enjoy a car ride as much as a pedelec ride, and electric scooter ride also not as much as a pedelec ride. This is something, especially all my American friends always told me, Hannes, you're wrong. We Americans, we are lazy guys, we want to throttle. But if you look at the market today, they all have a torque sensor and they all ride the Pedelecs because it's so much more fun. This is something which, unfortunately, you cannot understand in theory. Nobody can. Humans cannot do this. You have to experience it. And that's something what I learned in Japan, where the Pedelec was the first success. People did test rides. And after you test ride it, it's kind of, it opens your eyes and open your mind. Everyone who tests ride in Pedelec will end up buying one and riding it. This is something what I experienced in Japan, in Europe, in US, in China, and for sure the same will happen in India. Key is test riding. For the Pedelec, the electric bicycle is also from 1885, 1932. Philips made the first electric bicycle in the 1932. In production again, this was in the 70s. Then the Pedelec, this was the major breakthrough because it's actuated not by throttle, it's actuated by the pedal. Then the batteries became more invisible, looks more like a bicycle. And actually this is graph is from 2012. So I expected major breakthroughs here. The battery integrated in the frame is standard since 2017. And I expect something with much higher integration, fully digital drivetrain coming now. And here I will show you some stuff. Here's my technology milestone bikes, which I selected to show you today. Actually, we stopped here with the energy storage innovation, lithium batteries. Here is something which is actually just the first fully digital drivetrain. You can see here, no chain. Also here, there's no chain inside. This is a pedal generator, and there's the motor. So this means that the energy of your body is digitalized and repeated in a motor and mixed by software, fully modifiable from the battery energy. So this means that with this device, it's like a laptop compared to a typewriter. The mechanical typewriter, in the moment you push the type, there's a movement and the typo goes boom on the paper. If you made a mistake, you made a mistake. With the laptop today or any computer device, even the smartphone, you type something, you don't like it, you change it as often you want, and in case you want to print it, you send it to a printer. And you can print it in color, you can print it fast, you can print it in big letters and small letters, you can modify it. There's no limit because it's all by software. This is going to be the future. This is actually also not a really new product. It's coming from Korea, from Mando, one of the big automotive suppliers. And you will see the next years, we will have many, many of these drivetrains coming out. And it will be much more fun, as you can imagine, ever you have had with a bicycle. And also, I believe that Tour de France soon, everyone will ride this because it will help to optimize your sports and your joy. And when you have joy, you're more active and you will ride more bicycles and you will just love it. This is drivetrain technology. Another thing is the bicycle is a very prehistoric thing today because you have so many manually produced parts. And this needs to change to transform to a fully automated production. And to make this possible, also from environmental point of view, the aluminum frame as of today, which is typically done in countries where manual labor and environmental damage cost nothing, or at least people steal it, steal the time and also damage the nature. like Cambodia, Vietnam, China. These are countries where most of the bicycle frames are made today in sweatshops. It need to go to a raw production. And example here, this is a bike with a plastic injection molded frame. This actually comes out of a machine. To my opinion, it's still too complicated piece. It will become more simple and higher integration. So this means that the future Pedelec, maybe also electric scooters, two-wheelers, will be made of thermoplastics. Thermoplastics are easily recyclable. The mistake here is still painted, but these are details. There are other manufacturers now who have non-painted solutions, which can be recycled many, many times. And also the ecological footprint is very low because you don't have to have aluminium, which needs a lot of energy and mineral resources. Here you can make this from oil, and you can circle this many times. And especially, you can also make a very detailed construction. This is also not new. Here's an electric injection molded bicycle from the 1980s from Volvo, the Itera. But at that time, the plastics haven't been that good, so it rides a little bit wobbly. This one is extremely stiff and perfect ride. So that's also there's quite long development time here. In the last 40 years, the polymers have improved a lot. What has been very important is the image of the electric bicycle. The electric bicycle had in Europe quite some time negative image. It was something where especially men considered that it's unsporty. It's only for old people which may have a heart attack or have trouble with their knees, or somehow you must be sick to ride an electric bicycle. Actually, this has changed in about 2008 when the first electric mountain bikes came. This was the first modern electric mountain bike made by KTM from Austria with a Canadian drive system from Bionics. And actually, the owner of the company, Miss Carol Ukov-Chen, she said, I don't believe people will buy this because a mountain bike is a sporty device. But it was crazy outsold. And today in Europe, most of the electric bicycles are electric mountain bikes. And often the price tag is higher than a simple car. 5,000 to 8,000 euros is quite normal. These are some examples. And people are very proud of it. They are showing this off to their neighbors. And it's a prestige object. This is one trend, the sportiveness. Also, you can see like a Maserati road bike. Also here, people don't discuss about the price tag. If this makes sense or not is another subject. At least people have a lot of fun with it, and it helped the image. My personal motivation is not something like this. It's about transportation. And so I'm wondering how most of the society in the world can have a affordable, fun and comfortable, safe transport. And so that's what personally I'm looking forward, and therefore technology is important. Here you can see also a major trend in Europe, cargo bikes. Many people ditch their family car for a cargo bike. So this is the big trend, especially in urban areas. And typically, these are real car killers because it's a lot of fun. And like here, there's 2 seats for 2 small children. Actually, here are 4 seats for 4 small children or maybe 2 bigger children. But anyhow, most of the children also now get electric bicycles quite early, like with 8 to 10 years. They're also getting their first electric bicycle. And that's the cool thing. Anyhow, these devices are sometimes crazy expensive. Like this one is about 8,000 euros. I think you can have probably almost 2 cars in India or China for that. And still, people love it. To be my opinion, we will need also much more affordable products in this range. And this will be possible with reliability. This means that products are very long living and can be tuned to next software or new hardware, maybe newer battery, but therefore it needs standard interfaces. And there we come to the subject again, to public charging, standard charging infrastructure. So we learned from China and also in Europe, a lot of these incidents. It's about safety. It's about the location. You should not charge such a product in your home, not in the hallway. And also many people worry about theft. So it's about safe charging, safe parking, and security, anti-theft protection. So these are the topics. Another topic is convenience. Why do people take a bicycle? Because the bicycle is something you can use from your home directly to your target place, like in front of the shopping mall, in front of the school, in front of the government office, of your factory, whatever. And you can go point to point. That's something which you can't do with a car today, because the car needs a parking space, which is quite big. And with a light electric vehicle, it's much more likely that you can park right in front of the building, in front of the train station, or like it's common in Netherlands today, inside the train station. They have huge parking lots for thousands of electric bicycles under the train tracks. So this means when you go by electric bicycle, you save incredible time, because you can go from your door at your home, inside the train station. You just take the escalator to the train track and you go. And when you arrive at the next city, you take a sharing pedelec or bicycle to go you to your final destination, which is included in your public transport ticket. And you have the annual pass. In Netherlands, actually the kingdom of cycle infrastructure. If you want to learn something about that, I can just recommend go to some of the interesting Dutch cities and have cycling tour there. You will understand that's the future. And also, I'm, as a German, have to say, I'm always jealous when I cycle in Netherlands. And we are probably 20 years behind Netherlands in Germany. And I believe the whole world need to learn a lot from over there. And still, Netherlands is improving. So they're running ahead. They also talk about parking infrastructure a lot. You need safe bicycle tracks and safe parking. How about parking and charging? There are many ways, so I will show you some ways. What was done in the world. Looking to China. This original wall mount standard public charging infrastructure from China. You have to insert a few renminbis here, Chinese coins, and the new ones, this one is already 5 years old. The new ones all have WeChat Pay and Alipay. Of course, so you can, with your smartphone, you just go on the QR code and then you start charging. But here comes the interesting thing. You have the most common Chinese charging plugs here. You can see many of them look familiar, like this is like an audio or antenna port. This is like a some AC outlet, but actually it's DC. or this like some computer plug, and you just plug this into your vehicle. This was easy going when all the batteries have been made by lead-acid battery, and they all have the same voltage. Now, see, this all comes from this cable. Now this is not possible anymore because also China, the dominance is lithium-ion batteries, and the danger potential is much higher. Here, you may kill your battery, but it's not a fire hazard because the battery, lead-acid batteries usually die a bit silent. Okay, that's history in China. Another thing is also a Dutch company coming with this. You have inductive plate and you have coils inside your stand, and they can charge the battery. The problem is that if someone wants to get to his bike, he may move your bike, or the coils are not properly connected at the right spot, so the charging will stop. It's also not an anti-theft device. You can just lift it. It may work for very heavy scooters, which are not so easy to lift, and probably only in some areas in India you will have the problem. Snow, if there's a lot of snow coverage, it doesn't work anymore because when the distance is too high, like you have maybe 5 centimeters of snow, it will not charge anymore. So you have to always clean the floor. Now I'm coming to the standard interface. There was this kind of version here. Maybe you come a little bit closer. This is something from a pilot project where different companies like Stromer from Switzerland, Flyer also from Switzerland, and Panasonic make the drive system. Here is the drive system from Taiwan inside. We try to make a charging and locking technology which can work with different drive systems, different voltages, and it was look like this. This is today also harmonized by IEC, the standard charge connector for batteries, not for vehicles anymore. And it was combined here with a metal cast locking mechanism. So this means that inside the bicycle frame, we have this hole, which can also lock this, as well as inside here, the infrastructure, we have this cable, and it could be also used with this metal ring to lock against, for example, a tree. There could be the tree here. Of course, you cannot charge from a tree, unfortunately, but you could lock to it. And this is like many cars have today. You have the infrastructure you lock into, and you have the vehicle you lock into. So this was the solution, and it was made with Abus, famous German lock brand, and it was heavy, a lot of steel. They believe it must be heavy to be safe. But we learned a lot from this project. This was 2011, 2012. We learned that steel, a heavy lock, is not safe, because with modern thieves technology, like a battery-powered hydraulic scissors, you cut any steel lock in seconds, and it doesn't make a big noise. Or you have a battery-powered grinder, a bit more noisy. Anyhow, it's so quick, you can steal anything. That's why we learned the bicycles itself must turn themselves to electronic waste in terms you steal them. And it's enough you make it not so easy to steal. That's why we made a lot of improvements. And I will show you here the last version, which also became now international standard. This is a sharing electric bicycle from Switzerland. Actually, this is from 2015. And here could be nice integrated. There is a cable with a socket fixed to the vehicle. There are many versions, could be also much more beautiful, how this could be integrated. And now you have this fixed to the vehicle and this socket. It shows blue, it's ready. And now it's locked and it's charging. Cannot pull it off. It's also fixed here. So if I want to steal it, I may take my pocket knife and cut it. And it's just rubber and copper. Maybe this will also be bad, but actually we believe the future of bicycle security for anti-theft is just very thin flexible cable. Because this device and device will always talk when communicating. If you unintentionally drop this or unauthorized this, device will know, okay, I'm stolen, authorized, remove, and the station will know product was stolen. Station can do something with the information, for example, broadcast in the internet, and maybe your surveillance system from this incident or
Hannes, sorry to interrupt you. We sort of losing you a little bit. Not able to hear you clearly.
Okay. Maybe I was standing in the way of the microphone. Is it better now?
Yeah, it's perfect. Thank you.
Okay. Yeah. Thanks for announcing. Just put it back to the front of me. So this is the security idea, and this vehicle may have a 24-volt battery system, maybe 36 volt, maybe 48 volt, maybe 55 volt. All this is possible because the AC-DC conversion device, which supplies the DC current, will only switch on when the vehicle battery management system or the vehicle control unit tells the AC-DC conversion device what it wants. It's like in a restaurant. You can order what you want, and you have a standard language. This is using can open. Can open is like English for machines. It's the most spoken machine language in the world. Billions of devices talk it. If you go to train technology, boat technology, military technology, any machines or any police vehicle, medical vehicle, big building equipment like caterpillars, all the controllers in the different parts of the vehicle talking to each other with can open. Can open is standardized since 1992, and energy bus is just another word for can open 454, which is a specific vocabulary book for light electric vehicle topics. So that's why this communication is used. Now I'm going somewhere, and because this is connected to the internet, maybe also my vehicle, I may check on my app security status, it's okay, and I can also see the charging. The point is, the electricity on this standard interface should be always free of charge. Because in the moment you sell electricity by kilowatt hours, you need a approved and also recalibrated energy meter. And this is very expensive. So that's why the consideration is that only parking time is counted. And there may be different models. Maybe cities even give this free to their citizen under special conditions. For example, that you don't park there for longer than 48 hours. And if you park longer, you may pay something. Or at the train station, it's maybe a shorter period. So actually, you can do management of parking space. And parking space is public space. It's like gold of the city. The city should not waste it as today for cars. Just consider on one car parking spot, you can have at least 8 light electric vehicles, even a little bit bigger like the cargo bikes. So how to unlock it again? This could be on my smartphone. This could be with an NFC tag on my bike. Like here, there's an NFC reader. But it could be also, like in this case here, I just enter a code, and now I can unlock it and lock it again in my vehicle. I can also use this, for example, to lock it to something else. Like if I have only a street pole, of course here I cannot charge, but I can also lock it to the bike itself. This is an example infrastructure which also has a coin locker. This is another method to charge in public. You could have here, for example, your charger and your battery inside. If there's a fire, it's just very locally and it's also outdoors. So it's not so much hazard as when you charge in your apartment. The cheapest way to make parking infrastructure is not to have such a complicated device. It's more have a pole, still a complicated pole with a square shape, a round pole. Round pole is the most effective way to do a pole because it's very little material, or a wall box. Maybe just have a box screwed to a wall. In the moment you have a pole, you need electric cable to go there. I believe also in the future we will have many infrastructure which may come with a roof and PV system and a storage battery, which is actually independent from the grid, which would be very helpful to have renewable energy locally. You don't have to dig. You have a complete DC system. So you are voltage directed. So this means that from safety point of view, also not trained electricians can operate it, can change some parts, because the risk for electric shock, if it happens, not treating your life. That's why this is the approach. This is also already an IC standard. So this is the international harmonized standard for light electric vehicle charging. There are also ideas always about, is this maybe too complicated, too expensive? We believe that this is the cheapest solution, which is also safe. In China, they always use the AC/DC conversion device in a separate box. That's also how it's used at the moment in Europe. Like one of the most popular drive systems. And just if you look, this is the AC/DC converter from Bosch. Actually, it's made by another supplier. And the cost for this device when Bosch buys it is about 15 euros. And when you buy it as a consumer in the shop, it's about 170 to 180 euros. Why so much margin? Because it's proprietary. It's a specific connector. If this is a standard connector, it will be like USB. The AC/DC conversion device may not cost like before when you buy it from Nokia or Ericsson or some Sony. It's maybe 30, 40 euros. Even production cost was 3 to 5. No, because now you have USB as a standard AC/DC conversion device. You may buy it for 6 euro because there's a free competition on the market. And you can buy more nicer ones and all kinds of versions so that it can fit your cigarette lighter in the car, or actually it's built into your airplane seat or in the train. Why? Because there's a standard. If you have these proprietary plugs, it will be always making money device for the vehicle makers or the system makers. And of course, also this one can show has again this house, tiny house here. And this shows it's for indoor use only. It's possible to make such as these converters, which can also be used in the dirt, in the wet condition, but it may cost 3 euro more, so nobody's doing it. That's how it works. And the other idea is that you have AC going into the vehicle, which means that you can save money on the infrastructure. I will show you the backstage of this infrastructure. Maybe Patrick should come around. This is the AC/DC converter. It's from a Canadian company, Delta Q. It's made for outdoors. It's actually made in a way that it can operate underwater. You should not need this, but also in the flooding, this could happen to infrastructure. The point is that this device is the most expensive part, the AC/DC converter. Something like this, depending how powerful it is, can cost between 20 euro and maybe even 500 euro when it's fast charging capable for maybe a small electric scooter. And it can charge maybe 3 to 4 kilowatt in DC current. On the other side, the core is that on the vehicle side, you always have below 60 volt DC charging current. This means that on the vehicle, there is no danger for electric shock, which could be harmful for life. All this stays in the infrastructure side. Maybe even on the infrastructure side, there is no AC/DC converter because you have solar, wind, water, renewable energy collected locally, and you have a big station battery, and everything is in the low voltage DC area. That's what I expect to become the standard, the new normal for light electric vehicle parking and charging infrastructure. Of course, when you have in big apartment buildings, maybe 500 of such stations, you may have this grid connected because anyhow it's downstairs, maybe it's also indoors, like in a former car parking lot. There are many projects around the world with different infrastructure approaches. Actually, none of them are harmonized, and most of them have specific connectors. This means that you have some connector fixed on the frame, for example, and you have to lock the vehicle to the infrastructure. Many people don't like the cable, but the good thing is this cable on this vehicle is the same as this cable on this vehicle. So you can see the scooter could be plugged in here in the same way as this bike as maybe a big scooter, a cargo bike, a two-wheeler, three-wheeler, four-wheeler. If we have a pole and a cable, any vehicle can go here. The only point is that the vehicle maker has to design in the cable. I would say this is just the starting point. Could be much nicer. I can give you an example how this could look like. This is a manufacturer who designed it in more beautiful. Just give me a second to pull up the picture. This is the way how it was integrated by the company Heisenberg. Actually, now Heisenberg is owned by Hero since not too long time, and they made this, integrated this cable in the seat post, and you make the cable rest in the socket under your saddle. And this is a pole for two bikes. That's how it could look like. Anyhow, there will be unlimited designs, and if you have these poles and the cable fixed to the vehicle, you can see the vehicle can have any shape. That's the core of interoperable infrastructure. And also that you have this protocol which enables infrastructure manufacturer to say any electrochemistry, maybe future battery technology, which has different requirements, can be also charged because it's neutral. And maybe you have an existing vehicle, for example, this is the adapter cable from Bosch to the IC standard. Also, this is possible to create such adapters. Of course, the safety, the anti-theft protection is not possible anymore because this gateway may not be able to talk so much. And this standard, this is the also IC standard magnetic connector. From this connector, available now since about 10 years. Several million units have been sold. And this is magnetic. Actually, it's also, so it's cannot put it in the other way around. It's also waterproof in the connected state. Very popular. This is from the Swiss brand Stromer. So for charging the battery. So there are two connector standards now in the world from IC. One is this one, which is for charging or connecting from the AC conversion device to the battery. And if you want to connect the vehicle to the infrastructure, then this is the standard connector. You may ask why here's only 2 pins in this order, and on the socket there's 3 pins. Yes, there's also another connector available with which using these 2 pins. This is if it's above 60 volt. That's what the safety division of Bosch required in the early development stage, because if you're above 60 volt, for example, to charge a motorcycle, 120 volt, this makes sense to have a separate pin on it. So where are we now and what will be the price tag for this? At this moment, all these samples which I show you are 3D printed prototypes. We have had several stages to prove the technology. Interesting thing is, you may wonder what's the difference between these connectors. Actually, both have 6 pins. This is 12 volt auxiliary voltage to wake up, for example, the electronics in an empty battery, which is on sleep mode. This is CAN high and low, and this is the power. Here, these 4 pins are in this field, and they are not conductive pins anymore. They are behind the NFC coil. This means that there's a, like you know this from your NFC card for your payment, or in your phone you have this NFC function. You can transmit a little bit energy. So the assist voltage, the 12 volt, is in the energy goes through NFC, as well as the CAN communication is transmitted via NFC tag. Why do we do this? Because we learned in outdoor application, such tiny pins may not last very long. And we need something in outdoor which should last maybe 30 years without service, and should last under hot, cold, dirty climate. And we found that these 12 volt pins in the socket, if they are installed like this was in a prototype infrastructure, if they're installed in an area near the sea where you have salt in the air, together with street dust, this can within 1 year build up electrical connection. So that's why here there's only a magnetic field in this area which does the communication. So this should be really robust and long living product. What's the way on getting this really anticipated? In 2015, our European Ms. Violetta Bulc, she is the European kind of Minister of Transport, EU Commissioner for Transport is the correct naming. She watched this, and actually the person in charge in her position before she was in power started this project because the European Union asked for this, actually. And this was in 2010. So this project was started by the IEC because the European Union mandated that it need a harmonized standard. So actually it's a European government request. And I've been working on something similar almost 10 years before for DHL, Deutsche Post, for charging their electric bicycle cargo fleet. And so we brought these together in the standardization and worked on this. So since 2017, we have in December 17, it was decided. And now we have done several fleet tests and verifications. And another European project now is making a pilot application this summer. And we're expecting mass production in several thousand next year, and in several 100,000 millions in 2023. So I hope that this will become really fast available. Any company in the world is allowed to manufacture this. It's like household socket. We are looking forward to have a full competition here and have the best companies making this long-living, robust, interoperable solution happen in the market, and help to save lives of citizens, because the fire hazard is reduced, because you cannot, like here, connect things which may not fit together. maybe they fit mechanically. You squeeze it in, but not electrically because they have the wrong voltage. The battery may be overcharged. Overcharging is the most common reason for burning battery. Monitor want to go to energy save mode. It's a good one. Saving energy. Yeah. So that's why this is not the solution. And also, for example, these coaxial connectors, which are used by many products, they are most prone that they unintentionally fit because they are all somehow similar, and with a little bit force, you can make connectors fit which should not match. And this can cause hazards. So that's why it's very important to have a connector which connects, communicates, and only when both devices, like the vehicle, the battery, and the charging infrastructure or the AC/DC conversion device charger, is considering it's safe, which also means that this interface, which is from manufacturer A, like Taiwanese company, High-Tech Energy, and here, company Stromer, you connect them. If this device is broken, you only talk to this company, and it's their issue to give you warranty or fix it. And if the battery is broken, it's only business of Stromer because it's their device. Today, it's always a system, so you can discuss maybe the charger damaged the battery. If you have a standard interface, it's very clear. Only this device has his warranty until here, under the standard interface. To give you an example, you rent a home, apartment, and you buy a vacuum cleaner. When your vacuum cleaner, you plug into the wall socket. When your vacuum cleaner is broken, you talk to a vacuum cleaner company, not to the electrician who built this house installation. Because it's clear, it's a standard interface, and the electrician warranties that the interface is according to the standard. So this plugging the vacuum cleaner into your household socket should not damage the vacuum cleaner, because it's a very detailed, described interface. If there's a mistake, of course, this can be traced also by a third party, because you have a detailed standard interface description in the IC standard, and any third party can witness, okay, is correct, installed or not. So it's clear whose fault it is. And that's what we need. This will make it for vehicle makers, for component makers, possible to make much better products to much more affordable prices. At this moment, unfortunately, also in the European market, I can say we have a lot of proprietary systems which make products which are very expensive and very difficult to get spare parts for repair or to improve your product during the product life. So this is something which I can really recommend to prevent to happen. And what I'm considering is that the market in India has the ability to learn from these stories, which I just partially told you, to really go the fast track. And maybe an example is what is in the last happened in the last 20 years, which is very impressive. When you look to China with the high-speed rail trains, China started extremely late to make high-speed rail, but learned from Japan, from France, from Germany, bought their systems, learned everything, and made it better. And now China has much more high-speed rail tracks as all the rest of the world, And this was, they just overcome many of the issues the others had and learned from all their experience and did it better. And that's what I wish for India, that you learn from technology side, but also from legislation. That's why I will show you some slides about legislation. As I told you, there's a lot of discussion. For the right slide for you on what is an electric bicycle legally. And there is a major issue which is caused in the past. Actually, it's the definition in the Convention on Road Traffic. It's done in Vienna, in Austria, 8th of November, 1968. At this day, the United Nations agreed on vehicle types. And they defined all kinds of vehicles, and all governments in the world have to reference to this, all standards have to reference. And this means what a cycle is. A cycle means any vehicle which has at least two wheels, could be more, 3, 4, whatever, is propelled solely by the muscular energy on, of the person on that vehicle, in particular by means of pedals or hand cranks. Could be also different. Key is a bicycle cannot have motor. If it has a motor, it's either moped, motorcycle, probably a power-driven vehicle, or a motor vehicle. So this means what we learned earlier today, what the Japanese did, they made a law which says if it's not more than 250 watt and a ratio of 1:1, in the beginning at least, now it's 1:2, it is a bicycle. It's considered as a bicycle, even it is originally a power-driven vehicle. And actually, my proposal is, which I promote since many years, is that we just rephrase the sentence. And this is something which is the base to have this vehicle really becoming globally a success. So the point is that it's like electronics going into the mechanical product. We can improve the safety. So my proposal is cycle means any vehicle, and just cut this, which is propelled, also cut solely, by the muscular energy of the person on that vehicle, in particular by means of pedals or hand cranks, and optionally by an electric assistance system, which is limited in its performance so that the safety level of the vehicle remains equal to or better than that of an unassisted cycle. What could this mean? We have a very concrete proposal on this. It could mean that we take a good bicycle, a road bike, and consider that the electric assistance is allowed to compensate the additional drag compared to a road bike. So this means that any pedelec would be as easy to ride as a road bike, even it's maybe a cargo bike. The motor can just compensate the extra weight. But if I stop pedaling, the motor would do nothing. So this blue, you can see the result on a flat, slick road between power input, like with 100 watt of muscle power, which most of us do easily. You go 25 kilometers per hour on a flat road. If you go up a steep hill, of course, this is dramatically different. And the idea is that the motor will just add energy to make everyone able to go like on a road bike. And people who are more weak, for example, children or senior citizens, they may not go so fast, because also with the road bike, they would not go that fast. This would improve safety a lot, because we have a lot of accidents currently, because people go faster as they are capable to control their product. Of course, downhill, no one can stop people, but on the flat and uphill. So this is quite simple to understand. That's what we are proposing. Actually, I don't know if it's easy to understand. I think it's very simple. I recommend to think a little bit about this. And the big risk is that we have vehicles which are at the end motor vehicles, and which need a helmet, a type approval, insurance, a driver license, and they are limited. They have a minimum age to drive it. It's quite important, especially also for cargo bikes. This could be extremely relevant, and especially when you see like a cargo bike, very, very popular. Most of them have a total weight of 250 to 350 kilograms, and therefore also a strong motor is a safety feature, as well as you can integrate a lot of electronic safety features like ABS, like anti-blocking braking, anti-slip control, anti-slinger control. All these things you can have this if you have such a electrical power, electrical controls in your electric two-wheeler. Yeah, so that's a lot of potential, but I think we already talked quite a lot. Maybe it's time also for your questions.
Yeah, so thank you, Mr. Hans. So I would first like to ask you, like, according to you, what would be the next breakthrough in LEVs?
The next big thing,
Yeah.
the change to highly automated production and the digital drive. There's a lot of room still for improvement in the electric motors and also in battery technology. But most improvement I expect from software.
Okay, thank you. Anshul, you had a question. If you want, you can unmute yourself and ask Mr. Hannes.
Yeah, thank you, Shaswat. Am I audible?
Yes, yes, please.
Yes,
Continue.
I can hear you. Yeah.
Okay, before going to my question, I would take few seconds as I couldn't resist myself to thank Mr. Hannes for making us through this particular facility. As because of this pandemic, we were launching since long, to pay a visit for such a repository. So really thankful to Mr. Hannes, and the points which you have touched during the complete session, like LEV's chronology, battery safety, driveline technology, Pedelec, parking and charging. They're really awesome. I personally like this session a lot. So now,
it's my big pleasure.
So now coming to my question, I just wanted to know your views, Mr. Hannes, and this is related to how should a country like India, for example, should go ahead with the adoption of electric vehicles. Maybe here I'm not talking about the EVs with respect to your electric bikes, because I'm not sure how Indian government is going to that stringent with respect to the road norms of electric vehicles, but I'm talking about the passenger electric cars, medium and heavy commercial vehicles. Should it be done through regulatory guidelines that has to be issued by the government, or all the OEMs should be, given some time to get matured, to validate, to adopt, such a technology? Uh, because what I have found is, since you are not putting a guideline, sometimes the OEMs are themselves are not ready to take up these technologies because of some cost issues and all. And if government is coming up with the regulations, sometimes we find that OEMs are not ready with the technology. So it is, I think, we have to take both the things hand in hand. So what are your views on that? Sorry for a long question, but yeah.
It's, I really love your question. And this is, I think, one of the most relevant things to consider. I would say one view is what to see how it happened in China, because I think we can learn a lot from China. China is a very strict dictatorship, and they had a lot of air quality issues due to too much combustion engine two-wheelers with mainly two-stroke engines in their cities in the 1990s. Very bad air quality issue. So the government decided to simply ban combustion engine two-wheelers. And within 3 years, all the combustion engine two-wheelers have been removed. This would not have been possible in Europe because in democratic system, if you take private property away from people, they will not agree and make a lot of trouble to the government. And maybe they change the government if they don't agree with the government. In China, this is very simple, and the government just did it. And the government gave grants to any company who pledged to make an electric two-wheeler, who said they want to do it. They got a lump sum amount, and they have to present their electric two-wheeler and make it available. And if it fails in the markets, it's their problem. It's not the government problem. And many of the electric two-wheelers which came to the market have been terrible from quality, really terrible. But this is kind of typical for China. If it's terrible, people just buy another one and try again. Complain a lot, buy another one. And the same for a manufacturer. So it's very wasteful, but fast. Today, Chinese electric two-wheeler makers can make a okay quality in huge quantity for a price which is incredibly low. This is thanks to government policy. If you want to change it, you need strong government policy. And when we look to the climate emergency, which we do have, we don't have time. And industry will never do it on their own interest, unfortunately. If I look to German car industry, they completely lost the electric mobility chance, completely, because they totally love their prehistoric diesel technology and gasoline cars. And just thanks to this crazy South African guy from US, Mr. Elon Musk, they had to run into electric vehicles to not lose all of their customers. Because the customer figure out electric cars are more fun, they're environmental friendly, and they are better than combustion engine vehicles. This is a very rare example of how technology made it in the market without government incentive. So electric cars became a success because of better performance, better image, and electric bicycles made it in the market in Europe, not because of any government incentive. The government just did, I would say, nothing, and still doing nothing. Because the Pedelec is so much fun to drive. It slowly emerged, and we tested here at Exnergy the first electric bicycles in 1992. Maybe I can show you these first 3 bikes. Actually, these 3 bikes are exactly the bikes from 1992. And this year, 1992, the world, we had about 5,000 electric two-wheelers at all, anywhere in the world. And you can see these bikes are looking quite terrible. A lot of cables and motor. Nobody would buy this today. What a bicycle looks much more sleek, trustworthy. But at that time, this was the best what you can get in the world. And just, of course, this is not really ready, but it works. People who really needed to go uphill, they wanted to ride a bicycle, but they had some health issues. They bought, and their neighbors have been laughing. This was not an old success. It has taken many years until it became a success because the product was more acceptable to the wide audience. It looked better. It had better performance. So it must match. But the Pedelec definitely made it to match. My hope would be for India to learn from the terrible legislation in Japan, in China, in US, in Europe, and make first a better legislation. And I believe you have really good people in your government. Important is don't be afraid to find us also as an industry. I understand most of you are from the industry side. Don't be afraid about making more complex solutions in the beginning. If you have a better product, better customer experience at the end, people will pay the money for it, and at the end, it will be a question of total cost of ownership. Also, people in India, back in the trips I witnessed this, have expensive smartphones, which may not think that they can afford, but what do people, when they want it desperately, they find some money for it and they buy it. Sometimes they emphasize, in my opinion, too much on manufacturing cost. Think about TCO, total cost of ownership. Find ways how to make it easily available to people on the street, so they can start using it and they pay it on the go, like you have a prepaid phone or something, and you pay each time you use it, and you may save even money because you don't use your gasoline motorcycle anymore, so you don't have to buy gasoline, and you can have very low cost charging coming from the sun. So you have financial benefit by using it. Maybe the product itself is something out of range of affordability, but the use is cheap. It's like you go on a train, you just buy your ticket. You can never afford a train, which costs several millions. And what should you do with a train? You want to have the mobility and the comfort. So that's why my recommendation, learn from other countries' bad experience, which means going for good legislation. Don't take it too easy in the beginning. The good legislation will help you to kick the market really big. Important is not the central government only, this is for the legislation, the local governments are very important. Why? The local governments, they have the power how the space in the city is used. That's quite important. That the local government allocates space to bicycle parking, bicycle riding, safe bicycle riding, and not give all the space to the parking cars and to driving cars.
Yeah. Thank you, Mr. Hannes, for your elaborative insight. Thank you so much.
You're welcome.
Okay, thank you, Mr. Anshul. Now we move on to actually our last question from the audience member, Mr. Anand Deshpande. If you would like to unmute yourself and answer the question, please.
Yeah, good morning, Mr. Hans. And it was a very nice session. We loved it. I have got two questions. The parking charging connector which you showed us, the green one. I think
Yeah.
that is IC 61851-25 standard, and also 62196-6 connector.
No, actually, I can show you just a moment. Some slide with the numbers on it.
The new Yamaha connector which has been published by IEC.
No, it's this is different. Many slides here. Just a moment. The Dash 25, what Yamaha is trying to push, is a very different approach.
So this connector also has got a IC number now, standard.
Yeah, it has this IC number. Many slides.
And it is specific to only electric cycles, or it can be used for LEV to Mr. Scooters or motorcycles in India.
To anything what is not a car,
Okay.
to be honest. But maybe some big electric motorcycles not use it because they may use the car interface. Here, I got it. It's the IC TS 62196-4, 4 Roman 2. And this is for describing the 3-pin version for motorcycles,
Okay.
up to 120 volt, and also the 2-pin version for everything up to 60 volt. And then in the ICTS 61851-3-4, there's another one without any charging current, only for locking devices. This could be for a mechanical bicycle, for example, or any other device. So this is was agreed by December 17. That's the time when it was frozen. And the Dash 25 series, what Yamaha is pushing, to my opinion, is from the safety approach, because they are lacking of a complete system. They have focused on an ecosystem which works still with proprietary infrastructure. Because Yamaha, as well as Bosch and also Shimano, they are trying to create infrastructure where they, as vehicle makers, can still create dominant market positions. But especially, I think, for countries with a lot of own potential in industrial production and vehicle industry like India, I think India is the only country in the world which can compete with the massive market in China, domestic market, and also production capability. Because from my point of view, in India, you have the core ingredient. The future vehicle, the most advanced technology will be in software. And in India, you have the vastest resources in good software engineers. And that's the chance I really recommend that you use this in India to build your own industry. And just to give you a hint, Yamaha was creating a lot of trouble in the standardization. They invested millions in unnecessary trouble and delaying the standardization process. Watch it carefully.
Okay, and the corresponding DC converter, the pole AC to DC converter standard is 61851-3 series.
Yes, exactly. That's the describing the communication. So in the section 3 is 27 of the -3 series was approved in spring 19. Actually, thanks to the activity of Yamaha, it's not finally published. The convener is also a guy from Yamaha, and majority of participants from different countries, all coming from Yamaha. So they're investing huge money to delay it. Anyhow, they will not succeed. And the 25 series was founded by them later. Still, the 25 series is not complete because it's not a complete ecosystem from infrastructure side, from vehicle side, with completely defined interface. There's always missing things. For example, they have no standard connector. They have no complete protocol. It's very exactly very simple items only. And if you want to manage, for example, as a city infrastructure from the business model, there is no business model with the 25 proposal, because the business case is managing the city space. So the city could manage the public space and ask for money if you inadequately use it. For example, you park a vehicle, a rental scooter, for several days. There could be a strong rising curve of parking space cost issued to the rental company. So the rental company will have incentive to move their scooter to another place where it's better used and not waste city space. That's a big issue of these shared vehicle fleets, which are all over the world happening. And not only in China, but also very strongly in Europe. For example, this is a picture which I've taken in front of the Berlin main station. And you can see here the different pedelecs and bicycles which you can rent. They're all free floating. This means they are standing somewhere in the way. These are the trend in China. It's all become a pedelec. And this picture which I've taken in Chengdu, this is at the bus stop. There are officials who are taken with their special law enforcement app pictures of the bikes, and they give the company a few hours to remove their bike. If the bike is not removed quickly enough, then the city will pick them up and just put them to big places outside of the city. These are not Dutch flowers with different colors. No, this is OFO, and this is OFO, and this is Mobike, and this is another company. So they sorted by color. This is you see this electric current transmission here. So this is huge. And the same thing we have. This is in near the train station in Copenhagen in Denmark. Public space is gold for the cities, and that's the charging is one item, and the charging is just a free service. Mainly it's about secure and convenient parking. This, for example, just bicycle parking system in Japan. If you go to Japanese cities, you will find that there are almost no bicycles somewhere wildly parked because it's illegal to park your bicycle anywhere. Only in your private ground, you are allowed to have your bicycle parked as you like. In public space, it's forbidden. So this means you have bicycle parking and you pay here. So you lock your bike and then you have to pay money to get your bike released by the bicycle parking system again. And these are also partially combined now with charging. But because of lacking standard, extremely difficult. Most of the public charging solutions which are so far built in Europe, like from big German electric utility company, they're absolutely illegal. They always use an AC outlet, and then you have your AC-DC converter, or this is in Austria, it's the same. And you pay some money, then this is switched on. Maybe you have an app, or you have a coin, like in China, the old one. But people can steal your AC-DC converter, and the AC-DC converter is not for outdoors. This is in Italy, same. You can see here, the open charger, even with air ventilation, so the rain can really go directly inside. And people have a multi-plug. This is okay if you do this indoors, maybe in a garage, but even there in public, you should not do this. So this is all around the world exactly the same problem. So I recommend think about this stuff first, and this will help you to grow the market much faster. Do it like China did on the high-speed trains. Learn from the mistakes of the others and do it better. And anyhow, for me, India will be the country with the highest chance to make it better. Because anyhow, the Chinese have had trouble to talk to the rest of the world because most Chinese cannot speak English well. And in India, almost everybody speaks very good English. So communication is easy. And you have the software. So please make it better as the rest of the world.
Thank you, Mr. Hannes.
Thank you very much. Thank you very much.
So with this, I would like to thank Mr. Hannes and his team at Energy Bus for giving us the time to do the session. It was very insightful, and we went ahead and we still had the audience members with us. So thank you, Mr. Hannes, and I really think that the government officials were able to attend this session as they would have learned many things from you this time. So thanks a lot, and we will post this on YouTube and hope some government official sees and learns something from a industry veteran like you. So thanks a lot, and we wish you good luck at Energy Bus. And yeah, so you would like to say some parting words.
Yeah, thanks a lot for your spending the time with me, and I'm pretty sure many things have been very fast. Maybe it's not so easy to grab all these things, but you're welcome to ask more questions, and I would be extremely happy to see that India will do a better legislation that we have in Europe or we have in China or in US, and you will make a fast track to renewable, human-friendly, and eco-friendly transportation, which is a lot of fun. Much more fun as getting in an SUV stuck in traffic.
Thank you, Mr. Hannes. Thanks a lot for your time, and we thank all our audience members who joined us today. So with this, we end the session. Thank you. Bye, everyone. Thank you, Mr. Hannes.
Bye-bye.
Thank you all. Thank you.
Thank you.